Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and today I'm going to talk to you about active processing. So far in our lessons on using processing, we've been writing static programs. The code is executed just one time, going from line to line from top to bottom, and then the result is displayed at the end, and it's basically just an image. So in some sense, you could say, well, we've been programming drawings, and you might actually think that's kind of frustrating. Like you could do it better and faster if you just drew that drawing in Microsoft Paint or Photoshop or something. But that's just the very basics of processing. What makes processing really fun is when you get into active processing. So active processing is this part of processing that replaces drawing frames 60 times a second over and over really fast, and that happens automatically without you having to do anything. And this is part of processing that's what makes processing special. This is not part of regular standard Java. So this allows us to do time-based things like animation and do active things that respond to human interaction with the mouse or keyboard or that type of thing. All right. So what happens with active program processing is that the program starts and then it just keeps running. So there are some variables and maybe constants that you declare at the top, and they're used while the program is running. There's a setup function. This is a special function called setup. It runs once right at the very beginning, and it does things like set the size of your processing canvas and maybe initialize some variables and things like that. It just runs one time. And then there's a draw function, and this is the really critical function. It runs over and over again until you stop the program. And the draw function is actually called by the Java virtual machine 60 times a second. And so if you think about movies, video was just made up of a series of static images that are played together in sequence really, really fast, and your eyes can't distinguish the different frames. And so that's what's happening with processing is the draw function creates a frame, which is a 2D image, but it does 60 of these a second, and so you get animation or what looks like video. All right, and also within that you can have the program respond to user input. So one of the things we want to identify is this idea of blocks. And so over here on the right, this mouse1D is one of the example processing functions, one of the processing examples that are built in. So when you download processing, you get a whole bunch of examples, and this is one of those. And it shows you these two really important functions, the setup function and the draw function. And what you'll notice is that the code that's inside setup is indented, and the code that's inside draw is indented. And the code is also enclosed by these curly braces. So here's an opening curly brace and here's a closed curly brace. Here's an opening and here's a closed, right? So this is called a block of code. And this up here, these 4 lines, this is called a block of code. So when people talk about blocks of code, they're talking about code that's enclosed between curly braces. And what we'll see mostly in this class is code that's enclosed between the start and end of a function. Okay, so every active program has this following format that it takes. Up at the top are the global constants and variables. So over here you see we have a couple of variables. And then there's the setup function. So that's over here, it runs once. And then there's a draw function. And this is the function that runs 60 times a second. So you don't want to put any commands outside of these functions. You might have other functions that you add down below when we start talking about how to create your own functions, but you never just want to put a statement like a line of code that's not within these curly braces once you start following this active program template in processing. And of course, we can do user interaction, and that's what makes processing super fun. So there are built-in variables as an example of this for mouse X and mouse Y. And this tells you the location of the user's cursor on the canvas, so you can do things relative to what the user is doing as they move their cursor around. And that's really cool. So you've got to know that these numbers they only change when the user's cursor is inside the canvas. And if the user's cursor hasn't gone into the canvas yet, they sort of default to being 0. And if the user's cursor moves outside of the canvas, then whatever the last values were when the cursor was in the canvas, the mouse X and mouse Y just stay at those values. They're kind of frozen there. There's also two others, PMouse X and PMouse Y, and these are the previous location of the mouse cursor. So this again relates to the frames. So the last time the draw function was called, whatever the mouse X and mouse Y were then, in this current version of drawing the frame, we can know what they used to be by calling PMouse X, PMouse Y from the last time draw was called. So here's an example called Follow the Mouse, and you can type this code in yourself, but I'm just going to flip over to processing and show it to you. So here's Follow the Mouse, and we have one global constant up at the top that's called float int diameter. This is going to be the size of a circle that we're going to be drawing. We have a setup function, which is very simple. It just says give us a canvas size of 500 by 500. And then we have a draw function, which sets the background and fills the circle, so we've got a reddish color, and draws an ellipse. Now, before I run this, what I want to show you is what this program looks like if you don't make it active. And so if we don't make it active, we wouldn't have the setup function, we wouldn't have the draw function, and maybe all we would have is this fill and the ellipse, and we wouldn't need this closing brace. So this looks like actually a fairly simple kind of standard processing program. And so we can run this, and you can see that there's a red circle. Now, it's not following the mouse because this is not made active yet. And it drew the circle at basically whatever mouse X and mouse Y were. My cursor hadn't gone into the canvas yet, so they were 0, 0, and with this diameter of 50. All right, so that's a pretty boring script. There's part of a circle up here. So let's see what it looks like when we make it active. We have a setup function that sets up the size. We have a draw function that's going to be called 60 times a second. And let's have a look at that. All right, so now it sort of looks the same to start with. Of course, we've got the bigger canvas size, but watch what happens when I move my cursor in here. Suddenly, this red circle is following my cursor, and it's following it really fast because what's happening is this canvas is being updated 60 times a second. So every time I move my cursor around, it's using those new coordinates to draw the ball. And the ball from the last time is it's disappearing. The reason that the ball is disappearing is because we have this background call. So every time we draw, we're actually drawing a whole new background here, and we chose 255, so that's a white background. So every time we draw this, we're actually drawing the background over and over again. All right, so that's one of the things that's what the difference between an active processing script and a static processing script. Now, what I want to show you is some really interesting things that happen here in terms of the background command and where you place it. So here we had it at the beginning of the draw function. I'm going to put it at the end of the draw function after we draw the circle. And I want to show you what happens when we do that. So now my circle has disappeared. And this is because I'm drawing the circle, but then I'm drawing the background, and the background, of course, replaces everything behind it. So now I have nothing. So it's a really bad idea to have a background function anywhere except for either the top of the draw, which is where we had it, like this, or we could also move it out of here and we could put it in setup. And take a second and think, what's going to happen if the background function is only in setup? Remember that this only gets called once. And if we don't have a background function in draw, so can you predict what's going to happen? All right, let's have a look and see. Aha. So now every time we draw this circle, we can draw them really fast or we can draw them really slow. We're building up and we're not replacing what's on the canvas. So this allows us to get this really built up look because we're not replacing the background each time. Okay, so that's kind of fun. So you really need to think about, what do you want to have happen? Do you want to have things build up as the user interacts or as your animation plays? Or do you want to have the screen completely rewritten every single time? And if you want that to happen, you need to put the background in the draw. Okay. So we're going to go back to looking at this. So background, we've just talked about. Put the background in the draw command if you want each frame to be drawn fresh and new, and put it in setup if you want your frames to build up on one another over time. Okay, so we've tried these different things, putting the background in the draw function at the start, putting it at the end after you've done your drawing stuff, or putting it in setup. All right, let's look at another example. This is PenDrawing, and this one makes use of mouse X and mouse Y, but also P mouse X and P mouse Y, the previous mouse location. So that one is down here. So this is a really simple script. There's actually no variable declarations at the top at all. There's the setup, which just sets the size, and then there's one single line of code. We draw a line from P mouse X, P mouse Y to mouse X, mouse Y. So from the old coordinates to the new coordinates. So let's take a look at this. Here we go. And what we have is your first little drawing program, because as we move the cursor, we get this line being drawn on the canvas. Now this is a pretty dumb drawing program because it does not actually, you can't stop drawing. You can't click the button to make it stop drawing, it just draws. Okay. So that's kind of fun. That's how we might make use of the previous mouse, X and Y, right? And let's think about animation. So what we've done so far is respond to user input with the mouse cursor, but you can also just have processing do things over time that are independent of what the user is doing. So imagine with the follow the mouse, where we've got the red circle being drawn, imagine if we wanted that red circle to get bigger over time. So we know that we have that global constant diameter. So I want you to think for a second, what happens if you try to do this? Diameter equals diameter plus 1. All right, let's go and try it. So let's go back to this program. So over here, so in our draw function, before we draw the ellipse, we're going to say diameter equals diameter plus 1. And we see that we have an error down here. It says the final field, followthemouse.diameter, cannot be assigned. And that's because we made it a constant, which means we can't change its value. So that's not going to work. So we need to make this a global variable. And we, of course, want to change it so that it's not all caps. And then we have to change it everywhere else. And not just there, but where we're actually using it to draw things. Okay, so now let's see what happens. All right. So now our circle is following the cursor and it's constantly getting bigger and bigger. Now this is kind of cool for a little bit, but then after a little while, okay, now this is just so big that it's not really interesting anymore. So we want it to get bigger for a while, but not continuously forever. So we made it into a variable, but it gets too big. So if we want to keep it smaller, what we might want to do is use the modulo function. So you learned about modulo, and you know that it gives us the number of times, the remainder of a division operation. So if we do something like x mod 50, that result is always going to be somewhere from 0 to 49. It can't be bigger than 50. And so if we do x mod 100, the result will always be something from 0 to 99. X mod 10 will always be something 0 to 9, etc. Right? So in general, x mod n will give you a number that's in the range of 0 to n minus 1. Right? And this is really useful. It's one of the main uses of the mod operator. Basically, if we want to cycle through, do something, and then come back and start over again, that's what we can use. Okay. So, for example, if we did this, if we had x equals x plus 1 mod 4, this is going to make x go through 0, 1, 2, 3, and then it's going to go back to 0, 1, 2, 3, and 0, 1, 2, 3. So it allows us to do things that are cycles. and that's really useful. So we might want to use cycle in our diameter and use mod operators. So let's have a look at what that would look like. So then we do diameter equals diameter plus 1, and if we do mod 60, that means that it's the diameter is going to get up to 60, but then it's going to go back to 0. So it's going to start at 50. It doesn't really matter where it starts at because it's changing, but the diameter will vary between 0 and 59 with this calculation. So let's have a look at that. Okay, and so what we have here is this sort of cone where the circles are really tiny and then they get big and then they get tiny again and then they get big, etc. All right, so that's an example of using the modulo operator to cycle things between big and small or that type of thing. All right, so that is the description of active processing. And so here's a summary. So remember that we create global variables or constants. They might be initialized at the top of the script. And then we have a setup block that runs one time. And you'll see sometimes in setup blocks, the global variables might actually be given an initial value in the setup block, often especially if they are dependent on width and height because the size command is in the setup block. And then the draw block runs once and it just keeps on running over and over again until you close the program. Now the draw block typically runs about approximately 60 times per second. That's the default. If the computer can do it, if you try to do really complicated pictures, the computer might not be able to manage to redraw 60 times a second. And later we'll see how to change this frame rate if you wanted to slow things down or what have you. All right, thanks for watching.